Video covers basic exponential equations and inequalities. In order to solve an exponential equation, what we do is we're going to use this fact that if we have an equation, so some exponent like b to the x power and equals b to the y power. So if the bases are the same, so on this side both bases are b, then we can conclude that the exponents must be the same. And that's what we'll use to solve these exponential equations, is we're going to use some number sets to make the bases the same in all these equations. So 3 to the x minus 5 is equal to 27. So right now the bases aren't the same, but what do we know about 27? 27 is equal to 3 to the third power. So we can rewrite this as 3 to the x minus 5 equals 3 to the third power. And then since the bases are the same, we can conclude that the exponents must be the same. So x minus 5 is equal to 3. And we just solve this like a basic linear equation. So we add 5 to both sides, and we get x equals 8. Again, right here, this was bases are same. So exponents are same. And all of these basic exponential equations, we will be able to rewrite them where the bases are the same. Later, we'll get to equations where we can't do that. But for now, this is going to be our best method. So 5 to the x minus 4 equals 125 to the 2x minus 1. Again, we're going to use this fact here that 125 is 5 to the third power. So now we have 5 to the x minus 4 equals 5 to the third to the 2x minus 1. And remember, when we have a power to a power, we multiply the two exponents. So this would really be 5 to the third times 2x minus 1. So power to a power, multiply exponents. And now the bases are the same, so we can set the exponents equal. So x minus 4 equals, and I'm going to go ahead and distribute here. So that's 6x minus 3. And from here, it's a basic linear equation again. So subtract x, add 3, add 3. So we get negative 1 equals 5x, and therefore x is equal to negative 1/5. The nice thing about exponential equations is we won't get anything like extraneous solutions, so you can check your work, but you don't. If you're confident that you did your algebra right, then everything works out. So moving on, we have 1/2 to the x plus 2 equals 4 to the 4x plus 3. So here we have to remember some more things about exponents, namely that negative exponents is how you get fractions. So 1/2 is 2 to the power of negative 1. And we know that 4 is 2 squared. So we had to change both. We had to change the appearance of both bases. So this is 2 to the negative 1 times x plus 2 equals 2 squared to the 4x plus 3. And now we have the same base, so we can just set the exponents equal. And I'm going to go ahead and distribute. So we have negative x minus 2 equals 8x plus 3. then again from here it is pretty straightforward. Subtract 3, we get negative 5 equals 9x. So x equals negative 5 ninths. This equation here, so this one we have an inequality. The nice thing about exponential inequalities is there's no special cases to consider like with radical inequalities. Remember, with radical inequalities, you have to find some minimum value because the domain is not all real numbers. But for exponential inequalities, the domain of each function is still all real numbers. So we just kind of treat it like an equation. So 1/16 is equal to 2 to the power of negative 4. Since I know that 16 is 2 to the 4th power, then 1 over 16 is going to be 2 to the negative 4th. And 8 is 2 to the 3rd power. You might be wondering, how do I know these things? Like just by looking at them. And the answer to that is not one you'll like. It's just that I know these things. The more you do math, the more you start recognizing patterns in numbers. So I see 16 and I just know that it's 2 to the 4th. What you can do, since maybe you don't have the same kind of number sense, is just start trying things out. Because you do know the way I'm writing these equations is it has to be possible to write them with the same base. So since you know 16 and 8 are both even, you might check if they're powers of 2. If you got odd numbers, you might check powers of 3. Most of the time, everything's going to be powers of 2, 3, or 5. So as long as you're willing to do some trial and error, you can always find the right numbers. Anyway, so this is 2 to the negative 4th times x plus 2. It's less than 2 to the 3rd times 5x plus 2. And just like with the equation, now that the bases are equal, then I can just solve the inequality for the exponents. So negative 4x minus 8 is less than 15x plus 6. And subtract 15x. Add 8. We get negative 19x is less than 14. And we divide both sides by negative 19. And we get x is greater than 14 over 19. Because remember, we divided both sides by a negative. So we had to reverse the inequality. All right, one last thing that we have for this is this compound interest formula, which is actually very similar to the interest formula we looked at in class, or just the basic exponential growth model. The only difference here, so we have A is the amount after t years, so that's like A of t. P is the initial amount, just like the lowercase a we looked at. The difference here is that we have this new variable n that shows up twice, and n is the number of compounding periods each year. So to compound means you add the interest on again. So you can see here we're dividing the interest rate by the number of times compounding, and then we're also multiplying it by the number of years. So it's really just splitting up the interest over some number of periods and then having that many periods. So investment account pays 4.2% annual interest compounded monthly. How many months are in a year? 12. So n is equal to 12 in this problem. And R is 4.2, which we have to convert to a decimal number. We have our principal payment, or initial amount, is $2,500. And we want to know after 15 years. So at this point, we just plug all the numbers into a calculator. 1 plus 0.042 over 12 to the power of 12 times 15. And if you type that all in correctly, you'll get $1,222,370.81. Moral of the story, invest your money wisely.